common thing sometimes people run into on the edges of their game, even using out-of-the-box game engine stuff. If they have like really skinny walls and really fast bullets, that's the sort of thing where it may not even. So even in the thing that we were looking at, I bet we could break it. Because what it does is it still expects a collision. And it knows, hey, if it's collided but it moved really far, we'll check the whole bounding box. But if it went fast enough to get to the other side all the way, there would be no overlap and it just would go through.
There's a lot of questions as to why you have such an element. But
yes. Well, potentially, and that's one of the things that you might run into if you're using delta time for your game and you have a low frame rate. What can happen is you'll have a further distance traveled because it's a greater amount of time between frames. Yes?
Does anyone else have questions?
Yeah.
So you talked a bit about performance when handling
Sure.
these kind of collisions.
Yeah.
And you also mentioned previously how you can use out-of-the-box solutions.
Yeah.
For example, Unity you talked about.
I guarantee they have quad trees.
My question is, how far can you trust an out-of-the-box solution? It depends on engine, obviously, to handle performance well.
And
is there any steps you could take to make sure that you're handling performance well when using collisions and these kind of boxes?
I mean, I would say anything that is generally used across a lot of projects has probably run into enough problems that it's solved them for performance. I know sometimes in Unity, like I've talked with other people who they may use like a Unity plugin that maybe doesn't do the best thing in terms of performance, and you kind of have to figure out why things are breaking. You know, in general, people get creative in games. If it winds up being something that, you know, it's not, you know, you want to build a giant level, and you know that's part of it, right? You know, just imagine for a minute that you have a tile-based game and it's huge, and it doesn't use quad trees, right? That sprite that's running around, that's the player, has to check every tile in the whole level, even if it's gigantic, if quad trees aren't implemented. So I feel like most would wind up figuring that out. You'd figure it out pretty quickly. Although, I mean, as a software engineer, I do know that there's a lot of projects out there that don't necessarily scale. They look really great in a demo, you make something small, it works great, you get bigger, and everything falls apart. And that is one of the problems that I have with using out-of-the-box solutions sometimes, you know, in certain cases is, yeah, it works great in this particular demo, but what happens when, you know, you're trying to make it work with a level that's larger than average on a mobile device, and then it craps out. If you don't have enough of the tools to be able to have different options, you might be stuck, or you may have to compromise your game. You may have to make smaller levels or something like that. Yeah.
I will also mention some game engine physics engines are not deterministic. I might be wrong, but I seem to recall that Unity's physics engine is not perfect, as in like not completely accurate to a real world situation, which is fine because video games, who cares?
Yeah.
But like if you're looking for that kind of technology and you're trying to make an actual, you know, real world simulation where I don't know, you're hired by the military, you want to make sure that your airplane simulations flying in the proper parameters, then maybe the Unity physics engine is not the best.
But, and again, to the point, I mean, there are, you know, as I was trying to show in those different phaser examples, there are different physics engines that you can use. I don't know a ton about Unity. I know it seems like out of the box, maybe it just tries to be as smart as possible and as efficient as possible, but everything seems to have gravity and friction and the potential to rotate and whatever. So I don't know what kind of massive thing they have under the hood, but it all kind of has to work together. I know, for example, in Phaser, they have different physics engines specifically to help you deal with that potential problem. And you can even use two at the same time. So I showed like it scaled from like the arcade physics, the ninja physics, which is kind of like in between, and added the ability to have slopes and stuff, and then the P2 engine, which is like a full-on physics engine. If you wanted to have a physicsy game, I think the one example they said, well, when I was looking into it, is like, why would you ever want more than one at the same time? For example, if you wanted a game, I don't know, I think their example was like a tank game that has to drive along potential slopes and whatever and handle physics correctly, but then it's shooting bullets in the air at a bunch of aliens. You can say, hey, the tank needs to operate with a real physics engine, like a more, you know, full, richer physics engine. But then the bullets and the aliens, that can just be arcade physics, axis aligned bounding boxes, and it's a ton faster. So that's the kind of thing that, you know, hypothetically you could do.
Thank you. You can make slopes by programming, and Nintendo can't even make slopes in Super Mario Maker.
Yeah. The quad trees, is that only used in 2D or also 3D?
I think honestly, I've never made a 3D game. I love 2D games, and the amount of time I have to invest into games is so small. 3D is just a thing I don't want to bite off. But I know that they have, at the very least, similar conceptual models in 3D games. I mean, I could easily imagine a three-dimensional quad tree. I don't know if that's what they do, but I'm sure they have something very similar for 3D games. Yeah. Yes?
Were you able to research and find different solutions for complex polygon shapes?
You know, I never researched it. I don't know. For concave, you mean polygons?
Concave.
Yeah. I don't know.
Like caves.
Yeah, I mean, that's a good question. I don't honestly know. I imagine any concave shape, you could probably, if you really needed to, you could break that apart into multiple convex shapes and then just say, hey, if this box is going to be in Pac-Man's mouth, you know, you split Pac-Man in half and you see is touching one half or the other half.
Quad tree, I just looked it up. Quad tree is best in 2 dimensions if you want to go through 3 dimensions. There's an oct tree, but it works slightly different.
Yeah.
Oh, what tree? Oct, O-C-T.
Okay. I did have another question. Is that is there a thing like with predictive physics engines where it'll predict that the collision is going to happen? Instead of, because right now it's like it happens and then it does everything. Is there anything like, well, obviously it's going to hit because it's going with speed in this direction and you have this much time?
Well, that is basically what an update function does. If you think about
It already hits.
it basically knows where it started from. So during that update function in the game loop, it knows where things were, and then it knows where they're going to be in this frame, and then it sees whether where it will go will collide. It is effectively already predicting.
But it's not like...
It doesn't draw it. It doesn't draw it out. So, I mean, you can really think of the whole collision detection piece as predictive of, you know, basically the way a lot of systems would work is they take all of the game objects, calculate all of their updates to where they would be, and then go through and resolve all of those collisions. And it basically is saying, stepping through moments in time, this is where it is right now, concretely, what is being displayed on the screen. Where will it be when I need to draw this frame? That is effectively predicting where it would be and whether there would be a collision in that scenario. I don't know what advantage there would be to going like further than that. Like, will this collide 5 frames from now? I don't know. I have never heard of anything that does that, but I'm not an expert, so maybe there is.
Unity does have a single command to predict where an object will go, depending on based off of its velocity.
Well, right. I mean, that's just basic physics, but I mean, that is basically what would be used in an update function. You know what the time is, and then you say, well, where will this be in X milliseconds. That is basically what the update function does. So I don't know, again, I don't know when you would want to use that with a time amount that's different than the frame, time. Like predicting something that's outside of that. I mean, hypothetically, you could, if you were going to have a ghost image or something, maybe it's actually part of the game where you want to say, where would this be, in this circumstance, but.
There's plenty of situations like puzzle games.
Right. Where is this Tetris block going to go? Although you wouldn't necessarily.
You're trying to throw a javelin or something to the effect.
Yeah.
And because puzzle games are less about being frustrated on how to execute the move, and
Right.
more about being frustrated on how to solve the puzzle.
Right.
You'd want to make sure that
Right.
something like throwing a javelin is a 100% predictable.
Yeah. In a hypothetical different Angry Bird, you could hypothetically, be pulling back on the slingshot and have it show where the bird would land. And that would be hypothetically something where you'd say, I know this potential velocity, where would it hit?
So that's a really good example of why one would want to do that. Law of game design. You want to make sure that it's as predictable as possible.
Yeah.
So any sort of visuals to indicate that maybe that goes to you throwing it out or something like that would be immensely useful.
Sure. Anyone else? Good. All right. Cool.
So these lesson night is free and all, or is it free? We also have after lesson night to, if you want to, you can donate to our speaker.
Oh, sweet.
Also, we have a winner for the next lesson night, actually. It will be vocabulary of Unity 3D, which actually, Greg, do you want to talk about it, or do you win that right now? Is it quick?
Sure, that's fine. If you want to work with Unity 3D, but you don't know any of its vocabulary, so for beginners, then it'll just be an introduction to all that, so you start making games and you don't feel like the language of it gets in your way.
Hopefully it will be drastically different than my crash course in Unity, which also goes through a lot of terms.
Yeah, it will be. It'll probably be more basic terms. But yeah. I'll make sure.
I don't know, I go through some very basic terms, like what the heck do I mean by model?
I might say so, what is a game object? So
Yeah, I also talk about that. I know, sorry. we can debate on. No, I didn't mean to undermine your presentation there. I'm really looking forward to it.
Awesome.
I'm glad, for one, I'm not writing your lesson, so let's put it that way.
Well, it seems like a really good perspective, I think. Really unique, so.
yeah, I guess so. It might be helpful. I don't have a coding background, so it's kind of the perspective that I'll bring to it, where I learned it. Yeah, my background's in English and language and stuff, so I'm going to take that with it.
Again, remember to check out our orbit. We'll go over this probably maybe